Today we're going to look at the derivatives of reciprocal trig functions, and so far we've been quite comfortable using sine, finding the derivative of sine, cos, and tan. Reminder, if we had something like this, if y was equal to sine of 3x, again, to take the derivative we would use the chain rule. So you would take the derivative of the trig function first, you would leave the 3x alone, and then you times the whole thing by 3, so your final answer would be 3 cos 3x. So the reciprocal trig functions would be the derivatives of cosecant, secant, and cotangent. Now I will develop cosecant for you, and then the other two, secant and cotangent, I'll just give to you, but this is the way we would develop our reciprocal trig functions. So the first thing I'm going to do is I'm going to rewrite cosecant as 1 over sine x, and then I'm going to write that as sine x to the negative 1, and now I'm going to take the derivative using the chain rule. So the derivative would be negative sine x to the negative 2 times the derivative of sine x, which is cos x. Now, if I simplify, I have a negative cos x in my numerator, and I'm going to move the sine squared x down to the bottom to get this. Now, I'm going to break up the bottom into sine x, and using our trig identities from pre-calc 30, cos over sine is cotangent, so this is going to give me cotangent, and if I move the sign up I get cosecant, so it's going to be cosecant x, cotangent x, and I have my negative out front, and that would be the derivative of cosecant. So again, the derivative of cosecant is negative cosecant cotangent. Similarly, I could do the derivative of secant the same way, and cotangent, but these are what the three reciprocal trig derivatives work out to be. So it's the negative of cosecant cotangent, and of course times the derivative of the function that's inside my cosecant. Similarly, secant works out to be secant tangent, and cotangent works out to be negative cosecant squared. So let's take a look at some examples. Okay, so our first example, we want to find the derivative of cosecant x squared plus 2. So to take the derivative, remember it's negative cosecant, whatever the function is, cotangent, whatever the function is, and then I times this whole thing by the derivative of the inside, and the derivative of x squared plus 2 is 2x. To clean this up, the 2x times the negative out front could give me a negative 2x, and then I have cosecant x squared plus 2 cotangent x squared plus 2, and that would be your answer. All right, we want to do secant squared of 2x, so you got to be careful with this one. First thing first, you want to rewrite it as secant 2x squared, so I have to apply the chain rule first. So the 2 comes out front, the secant 2x drops down to a power of 1, and then I multiply it by the derivative of secant 2x. Well, the derivative of secant 2x is secant 2x tangent 2x, and then I times everything by the derivative of 2x, which is 2. So now simplifying this, the 2 and the 2 become a 4. This times this is really secant squared 2x, and I still have my tangent 2x, and that would be the simplified answer of that one. For cotangent, okay, if we look back at our chart, the derivative of cotangent is negative cosecant squared times the derivative of the function inside cotangent. So to take the derivative of this, it would be negative cosecant squared 3x squared minus 4x, and I'm timesing this whole thing by the derivative of 3x squared minus 4x, which is 6x minus 4. And to simplify this, they might factor a 2 out of here and bring it out with the negative, so it would be negative 2. When I take a 2 out of that, I'm left with 3x minus 2, and I have cosecant squared 3x squared minus 4x, and that would be your final answer. So again, derivatives of the reciprocals, you just follow the pattern, similar to sine, cos, and tan, but they're just a little bit more tedious. Alright, for this question here, we need to use the product rule. So y prime is going to be my first function, which is e to the 3x, times the derivative of cosecant 5x, which is negative cosecant 5x. Whoops, let me just clean that up a little bit here. So it's negative cosecant 5x cotangent 5x times the derivative of 5x, which is 5, plus the second function, which is cosecant 5x, times the derivative of e to the 3x, which is e to the 3x, times the derivative of 3x, which is 3. Alright, so let's simplify this a little bit. The 5 here and the negative, I'm going to multiply it and put them up front, so that's negative 5 e to the 3x cosecant 5x cotangent 5x, plus I have, when I multiply these two together, I get 3 e to the 3x, and I still have my cosecant 5x. Now I'm going to take out my greatest common factor, and note I have an e to the 3x here, and I have a cosecant 5x, so I'm going to factor out an e to the 3x cosecant 5x, and I'll be left with negative 5 cotangent 5x plus 3, and that would be my final answer. So again, the product rule, similar as before, the only difference is now we're doing a derivative of a reciprocal trig function. Okay, for this question here, we are going to use the quotient rule. So again, y prime is cotan 3x, the bottom, times the derivative of the top, minus the top, and again, the derivative of cotangent is negative cosecant, whoops, should be a 3x times the derivative of 3x, which is 3, and then we have to divide that all by the denominator squared, which is cotangent squared 3x. And if I simplify this, I'll bring the 2 out front, so I get 2 cotangent 3x minus, well, this negative and this negative will become a positive, and when I multiply it by 3, it'll become a positive 6x cosecant squared 3x all over cotangent squared 3x. And yes, you could factor a 2 out of the numerator if you want, but we'll just leave our final answer as that. Alright, this last question, we'll look at an implicit differentiation. So again, I want to take the derivative of each term with respect to x, so this is going to be 3x squared plus 2 dy dx is equal to, well, the derivative of secant 4y cubed is going to be, remember, secant 4y cubed tangent 4y cubed times the derivative of 4y cubed, which is 12y squared dy dx, and the derivative of 9 is 0. So now I want to get all my dy dx terms on one side. So I'll subtract the 2 over to the other side. So I have 3x squared is equal to, I'm going to move this 12y squared just out to the front. And now I have secant 4y cubed tangent 4y cubed dy dx minus 2 dy dx, and now I'll factor dy dx out of these two terms, so I'm going to get 12y squared secant 4y cubed tangent 4y cubed minus 2 is equal to 3x squared, And now I move this mess over to the bottom over here, and that would be my final answer. So I'm going to have 3x squared over 12y squared secant 4y cubed tangent 4y cubed minus 2, and that would be my derivative. Okay, that concludes the section 4.2, derivatives of reciprocal trig functions. There's an assignment from your Calc 30 textbook, so give that a whirl, and if you have any questions, feel free to send an email.